Hello, this is Aki running. I'm going to run a demonstration of how to get started with Python, some simple machine learning. What you see on your screen now is my browser where I'm running some Python code. Um, Today we're not going to focus so much on how do you get here in terms of setting this up. You can easily look at tutorials on how to set up Jupyter, Anaconda, Python on your laptop, whether that's a PC or Mac. So today we're just going to focus on doing some simple machine learning, running through some examples and explaining some of the basic concepts. So what we're going to do is I'm going to code live through an example. This is going to take around 30 minutes or so. And I'm going to try and do the coding live here in this window. And we'll see the outputs of that code, and hopefully you can follow along. Okay, so for any kind of programming, especially machine learning, we're going to need some basic building blocks. So we're going to leverage some existing code so we don't have to write everything from scratch. These are called frameworks. So we're going to start by just importing a few of such frameworks. So the first few lines of codes is just doing that. NumPy is a scientific programming framework which has a lot of tools for mathematics and statistics and such, so this is going to come very useful. Next, we're going to import pandas, which sounds cute, but it's actually a file manipulation framework, so you can use this to read in spreadsheets, for example. Next thing we're going to import is a framework called Seaborn, which we're going to use to visualize some data, which is really helpful to understand the data. And then finally, we're going to import PyPlot, which is basically another framework for creating visualizations and graphs and such. Pyplot lib.pyplot. So if you're wondering what's going on here, all of these are things you can look up later online. The statement just means here that we're importing this framework, but so that we can make our code a little bit simpler going forward, we're going to rename it as NP, PD, SE, PLT, and so forth. You'll see how this plays out. The cool thing about running Python in a browser here is we can run each cell separately. So basically to check if the code works and run it rather than have to wait 5 minutes for the whole program to run and then spend another 30 minutes to figure out why it's not working. So this is a really useful tool, not just for teaching, but actually creating your own applications. Okay, so the next thing we're going to do is actually use our little pandas framework here to create a new spreadsheet or read in a new spreadsheet. So I happen to have this file ready for me, but again, you'll see that really we can use any Excel, CSV file that you might have from your spreadsheet program of choice. So we'll get into the specifics of what is this particular file, why have we chosen it, but you could think of this as just a basic customer data database output with a few thousand lines of various types of customer data. That's kind of an interesting example that generalizes well to different industries and different applications. Just, so it's some customer data. Okay, so this statement here is going to actually create a file that we can manipulate with. So df here is just the name of a variable that I've used to assign to this file and its content. So now we can sort of start using different commands from these frameworks that we've imported, pandas, for example, to look at the file. So if I type in df, then I can proceed to run different commands on the file itself. So again, you don't need to worry about too much about remembering all these specific ones. You can look these up. There's great documentation for all these frameworks. So you can look at pandas and find all the different functions you can perform on a file to see what you can actually do. So head as a function for a file just gives us this nice little overview of what's actually in this file, right? So it shows you the first 5 rows of content, and it shows us all of the columns that we have. So you can see there's things like account length, various timings. There's a churn kind of indicator. There's different statistics around calls. So you can probably already tell that this is some sort of like telecoms data. These clients are clients of some sort of call service function. So that's what you can see right away. But obviously you don't understand much of what do these numbers mean? What are the ranges of these numbers? So that's what we're going to try and do next, to understand what are we actually looking at in terms of this data. So the next command we're going to run is info. Very useful command. So this actually shows us all of the available columns that we have inside this file and the different data types. What does that mean? What's a data type? So here, for example, integer, int means integer, so those are whole numbers. Float means basically decimals. So they're numbers which have more than, well, basically more than 0 decimals. And then you've also got certain things like object. So state is actually this kind of like non-numerical label that's being used, and these are obviously look like 2-letter abbreviations of American states. Okay, so now we kind of see the lay of the land, if you will. Now the next thing we're going to do is examine these different columns to understand like what's actually in, what kind of data is in these columns more accurately. So if we run a command called describe on our little file, it's going to show us some statistics. So for example, how many different rows are there that have this data? So it looks like pretty much across the board. There's no empty data. It shows us the mean, standard deviation, minimum, maximum, and different quartiles in terms of how many values fall into the sort of different distributions within the data. So we can see that there's a lot of zeros in a lot of these columns in terms of the minimum value. And yeah, then you can look at sort of what is the mean and then standard deviation to give you an overall ballpark of what ranges is this data actually in. Now it really depends on what kind of data set you're looking at, but this is just a great overview for you to understand what you're really looking at if you're not familiar with the data set previously. Okay, so we can also do specific operations on individual columns, and I'll kind of show you how we can do that. So there's a general print statement, print function, which is really useful. So you can use the print statement to show any output of any function that you're doing if the normal output is not some sort of string which would show. So if we refer to a specific column in our file, then we can just refer to the name. So here we see account length. So literally in this kind of bracket format, this bracket is just referring to a column inside the data set. We can use one of those column names called account length. And now we don't want to print all of this data. What we're actually looking for is a specific function. So we can, for example, again examine individual columns to say like what's the minimum value of this specific column in this data set. And the result is 1, so it's basically what we already saw here. But this is just to show that we can manipulate individual columns rather than have to always just complete functions on the whole file or the whole data set as we did here earlier. Now the next thing we might want to do is some sort of visualization. So why don't we look at, for example, the churn column here. And let's look at, since it's pretty much a 0 or 1, so you can see the minimum value is 0, max is a 1, so pretty much we know those are all the available values. There's nothing really in between. So let's look at how many are 1s and how many are 0s out of those 3,300 rows. So the way we can do that, there's many, but this is one very simple one, is to use Seaborn. So this is one of the frameworks we imported here in the beginning. So why don't we use Seaborn here to do a little bar chart, just like you would in an Excel spreadsheet. So So that is called a count plot. And what we're going to do is feed our column here, which is called churn, right here. And in this case, we need to separately feed the actual file itself. So df is the variable that we've set for this file, so we're going to include that as well. And then additionally, what we're going to do is we're going to show the result. So you need to call a separate function for that. So let's see what happens. So that takes a few seconds to pop out this nice little graph. So we can see there's around 500 ones and the rest are zeros. So I guess that means that 500 out of those 3,000 have churned, i.e. those are clients that have basically left and are no longer using your services. So in this case, we're kind of interested in like, why is that happening? We somehow really, as a goal for this exercise, we'd want to drill down into this churn and understand like, why is that happening? What are the correlations between different things in the data set? And is that something we could train a machine learning algorithm to basically predict, so that we could see that, okay, these clients, they're at high risk of churn, so maybe you call them, maybe you give them some campaign or some special discount to renew their contracts or whatever. So we're trying to figure out what is the sort of commonality in these clients that are churning. So let's examine this data set a little bit further in. So since we're going to be doing more visualizations, I'm just going to run this little line of code, which is going to seem a little bit mysterious. And the reason we do it is just so that I don't need to repeat this plot show command every single time that we're going to run these visualizations. So I can just repeat the same statement from above. And if I now execute that, we should see, a nice little graph popping out. So that's just a little convenience feature that we're going to use. Okay, so let's explore some of the other columns. And one of the things we're going to look at now is this voicemail message. So we're going to look at people using voicemail and if that has anything interesting inside of that. So why don't we try a count plot, just like we did earlier, but this time we're going to look at voicemail messages. And again, we're just going to feed our little, I have made an error here, which I think is just this one character for the definition of the column. No, what's going on here? By the way, this is kind of a big part of coding, is you're going to make errors and you're going to have to figure out what's wrong. So I think in this case what's happened is I just missed the capital M in the column name vmail message. So coding is very specific and very particular about these kind of things. So you're just going to have to, unfortunately, deal with that. Okay, so what is this saying? It's basically telling us that there's a lot of zeros here. So I guess that means most clients are not using voicemail. Okay. So why don't we look at the geographic distribution then of these clients? So we'll run another of these, our favorite count plots. I'm just going to copy this over so I make fewer mistakes. And we're going to look at the state column. So this is the different states that people are in, and it's pretty much even across the board. There's no major spikes here. So we've got clients from all across America, it seems. Okay, so why don't we try to look at churn again, and this time we're going to run a pair plot. It's just another type of plot. You'll see what happens once we run that. So use the churn field again. Wait a few seconds. And it's going to produce a pretty interesting visualization for us to examine. Let's give it a few minutes to run. So what it's doing, it's basically trying to correlate all of the different columns in this data set to see how much correlation or how strong a correlation is there with churn and all of the other columns. So we're trying to establish really like what is actually going on here. Okay, looks like we're getting some sort of output. Just give it a second to run.